Welcome back. Let's take a look at a different solving technique for exponential equations. Let's just dive in. Alrighty, so here is our equation. So if the exponential part is not isolated, then isolate it. The previous examples that I showed you had the same base, and we don't give them all these other vertical shift, vertical scale, flipped upside down kind of things in terms of transformations there. Like I suggested before, once you understand this technique in the next one, go back to any of the examples and use one of the other techniques. Now, the same base only works with the same base. I am never going to turn 7 into base E. That's crazy, and that's super complicated. We don't need to bother with that. So as appropriate, I would not do the same base idea with this example, but take this technique and you get the idea. Alrighty, I think I had too many thumbs up there. So isolate the exponential part. There you go, undoing, just like we have done in the past. And suggestion, because the exponential base is E, use the logarithmic base E, which is the natural log. You can use any log base you want to, as long as you are putting it on both sides. But so for example, we could use log base 4 in this particular example. That would be an acceptable thing. But since the 4 exponent doesn't have an x, I want to do natural log with base E, and there's a special property that we learned a while back. Alrighty. So apply the natural log on both sides, and the property from before cancels the natural log base E and the E exponential base E and the exponent, and we're basically done. We've turned it into a super simpler linear equation. Subtract the 7 and you're done. I did at this point make the decision to put parentheses around the argument of my logarithm just to make sure everybody knows it's not 4 minus 7. So, suggestion, because sometimes our handwriting is not as good as we would like it. So make sure your old half-blind professor has an easy time understanding what you write there, i.e. use parentheses. Double check as before. Now, plugging all of this in to the calculator may be a little bit complicated, but if you are using the properties, because we use the same base here for the logarithm and the exponential, those properties will help simplify it, and maybe you don't even have to use the calculator, but you can type the calculator in. Again, type that value for x on the left side, do all of that arithmetic. Does it in fact equal 18? If it does, you are good to go. Next example, virtually the same thing. I'm using base 10 here. So when we isolate the exponential part, I'm going to use the common logarithm. You could still use the natural log if you want to, but again, when you choose those same bases, the exponential base, the logarithmic base, we're allowed to use that property to simplify that part. And then solve it. Like that. Alrighty. I think that's it.